You're going to put up your phone and take your hood off and participate? Why don't you try that? Take your hood off. Mark, okay, where's that? You're getting where your hood.
What?
All right, y'all don't need calculators anymore. Why don't you guys put those up so that, you know, we don't crumble the floor anymore? I know it wasn't intentional.
We're going to petition the school to have a prom king, a prom queen, and an iron.
Right.
Really?
She's going to be the Iron Queen.
Yeah. The Iron Man. The Iron Soldier. Iron Giant.
Go for your own Miss Iron.
Miss Iron.
Tyler, let me see your ears. Take tacks out. Put them up so they can charge. Take your earbud out. You know, the cord gives yours away. I got to see his ears to know if I need to yell at him.
You said what gave me away, the cord?
The cord.
Well, you know, I could have been slick with it.
It's a white cord.
You know, I could have
Just saying. Tired of it. All right, so what's a circuit?
I figured the circuit.
A what?
I figured that circuit.
A thing that circuits. Okay, you can give him a hard time for his answer too.
Oh no, an outlet that has circuits in it. It's oh no, it's in the phone, the little thing, little square things. It's a wire. It's a computer. We can bring a box to you.
As long as you can tell me it's a closed path that electrons travel, it's fine. All right, you don't have to tell me anything more specific than that. But you have to be able to tell me it's a closed path.
Can we just say closed path with electrons?
Jose.
Okay? Huh? Yeah.
This wall.
What?
It was that day.
I'm sure I can locate one. What? Did you cut yourself sitting in a chair?
No.
You got cut on staples?
Did you staple your hand?
No.
Shouldn't even have a stapler over there.
So you were
Oh my God.
You cut yourself?
Why would you think that? And it actually, you are bad. We're not friends today. We're back friends tomorrow.
Sorry.
Wait, Mario, did you think it and that it happened?
Yeah.
Here you of. I can't sit in the chair and not injure myself on a staple.
It's staples in my binder.
All right, so there are 4 parts of a circuit you guys are going to have. So what are the 4 parts I'm going to have in my circuit?
Wire.
Okay, we got to have wire. All right, what else are we going to have? All right, so what's that something that's going to close it going to be called? No, we don't call it a door.
I don't know.
I'll give you a hint. It starts with an S.
What's the N letter?
I'm going to ask you to open and close it.
Shot. Area. Downlander. What's the N letter?
SW.
Switch.
Yes.
Of
course, I'm worried about you opening and closing a salamander over there. All right?
Yeah. It's a little complicated.
What else are we going to have?
All
right, a battery, which we're going to call a power source. All right. I'm going to have a source. Now, this could be a battery or a motor. Unfortunately for us, I don't have any motors.
Yay.
So we will be using a battery. All right. Now, Mario said a light. For us, we're going to use light bulbs, but basically it's a load. All right. We will use lights because I have stripped Christmas tree lights And so we're going to use 3 light bulbs in our circuit. For us at the house, this could be a hot water tank, a refrigerator, our cell phone charger, our TVs, our stove, it could be our washer and dryer. It could be anything that we're powering at our house. For us, our circuit has to power 3 light bulbs, okay? But the load could be anything. Yes, dear.
Water, okay?
Sure.
Thank you.
Yes.
So a light switch is a circuit.
So the light switch is on a closed path. So every time I walk in the morning, the switch is open and the lights are off. So when I turn the lights on, I do what to the switch? I close it so the wires or the metal touches. And so I close the switch so the lights come on. So when I walk out this afternoon, I will turn the lights off and the metal will open so it's not touching and the lights will go off. When I turn the lights on, the switch closes, the metal touches, the lights come on. Off it opens, closes, it's on. Okay? That's the way all on and offs work.
You know Mr. Waring is back there?
Do I know of who?
Mr. Waring? You know Mr. Cruz commercial finance agent?
I do not know anything about Mr. Waring. Mr. Cruz got fired. It was in the dispatch. But I do not know anything.
Somebody said Cruz.
Really?
You said
Cruz. No.
Mr. Cruz got fired.
No.
I didn't know Mr. Waring was not here. Or did he get sick?
He was trying to graduate.
How long has he been out?
He's trying to get that iron.
How long has he been out?
How long has Mr. Waring been out? I just saw him like a week ago.
He's in an FPL meeting. FPL.
Yeah, Mr. FPLA was Monday, Tuesday, Wednesday.
What's that?
FPLA?
Yeah.
Future Business Leaders of America.
Will he be back tomorrow?
Should be here Thursday.
Okay, cool. So
Yeah, because Miss Hargrave's there too, because she told me about it last week.
Yeah, I was in career management with Miss Hargrave, and she used a piece of work.
Never mind. Anyways, they should be back tomorrow because Miss Hargrave told me about it last week. Okay? Everybody go with the parts of the circuit. All right. So what is a circuit diagram? A circuit diagram is a picture of a circuit using symbols.
Symbol for iron.
FE.
Miss Evie.
Miss FE, yeah.
Now, here's the part that some of you are going to struggle with. It happens every year. I'm going to show you the symbols that we have to use in the circuit diagram. Some of you will learn them, and you will draw them correctly on the test. And some of you will draw the real symbols for a light bulb, and I will mark it wrong every time. Because I'm going to tell you that you have to draw a circuit diagram. You have to draw the symbols.
Looks like I'm probably going to answer that question that you're talking about.
Don't marry me, I can mark it wrong.
It's not complicated to draw then.
It is not complicated to draw.
Is it like the ohm symbol?
And we're going to draw them now, and we're going to draw them on the lab. We're going to practice with it. It's not hard. So, a wire is a line. Okay? Now, a switch this would be an open switch. This would be a closed switch. You will notice that in the open switch, the line is not touching the circle. And in the closed switch, the line is touching the circle. Everybody see that?
Yeah.
Okay. Does that make sense? If it's touching, it's closed. Okay. I'm going to take your phone in a minute and you don't put it up. You sound like a beach seal over there. All right?
Mining for iron.
People at that
All right. Now, I know some of us can't write in cursive. Talked about this before, but you need to learn to sign your name. That's a loop or a cursive E.
I don't know how to loop this long.
And another loop. That's 2 cursive E's. But it's basically 2 loops. Okay? Loop, loop. Everybody got it? Put a circle around it. Sometimes they'll draw one loop instead of
That's a
two.
light bulb.
That's a light bulb.
Hey, let's all look at here.
Okay? Who's here? Lo and behold.
That's Mr. Iron right there. I got
Okay? So we got a light bulb. Okay? Wire, open switch, closed switch, light bulb. Now, you're also going to put resistance in your circuit diagram. So the thing that looks like an EKG is resistance.
EKG.
Yep. That up and down. Now, you're going to have to power your circuit. So short line, short line, long line is the battery. Now, I don't know if you'll see motors on the exam. Even though we don't have any, you might see some. So a motor is an M with a circle around it. Okay?
That's it.
Mm-mm. Nope.
All right, we're done for today. Good work, guys.
Nope. An A in a circle is an ammeter. Now, what does ammeter sound like? Amps.
Ampere.
So, what do you suppose it reads? Reads amps or current. Tells you how much current is in the circle. Just have it on the laptop. All right. The other one you might see is a V in a circle, which is a voltmeter. And a voltmeter would read what? Voltage, or how much volts you have. All right, let me see if I have forgotten anything. That. Nope, I think I got them all. Yes, dear.
Okay,
Don't tell me you lost it again.
no. Okay, so you know how we're test today, right?
It's just a quiz.
Okay, well, good. Whatever. But okay, so I didn't get to look at your what's that called? That online stuff.
Okay.
For Friday and Monday, because my internet don't come for Friday because some difficulties, and I had no clue if anything.
Did you do the review sheet?
Yeah,
Then you're good.
no, like, not didn't do it now, but I'm gonna do it.
Did you do it at home?
Yes,
Were you able to do it?
I looked online.
Were,
And then,
were you okay
but
with
I
the
don't
answers?
understand it. Like, I don't know anything.
I'm going to tell you. Listen when we go over it, see what you think.
And if I don't understand,
I'll make a determination. We'll see. We'll see. What?
Because he threw his pens at us.
Sorry. I was checking the list, see if I forgot anything. But I got them all there. All right. So the two kinds of circuits you're going to build. My electronics people should be familiar with these. All right. We're going to do series circuits. What's the other kind? Do I have any electronics people in here? I do in fourth period. I have two.
No.
What'd you?
No.
What were the two kinds?
Freshman year, I was in there.
So what were the two kinds? Series and what?
Huh?
What were the two kinds of circuits? Series and what's the other one?
He hated art class too.
You hated art class too?
He hated my class because I always had it sophomore year.
Just take class.
He just didn't like it.
these.
Yeah.
I might get back. I need to start getting the course.
Okay. So a series circuit then, since y'all don't remember anything, is a circuit where the electrons can only follow one path. Okay, it's a circuit where the electrons can only follow one path. Okay, they can only follow one path. So, as an example, so you have some type of model to look at. Suppose we have a battery. All right. And I put 3 light bulbs in. Since you're going to have to build one with 3 light bulbs tomorrow.
We gotta write it, draw.
Oh,
Yeah.
Well, I just broke both my wrists. I don't know if I'll be able to do it. I know a piece of iron.
Who draw that?
I don't care if you draw it or don't draw it, but you're going to have to build something tomorrow. Now, I drew a series circuit that has a switch, 3 bulbs, and a battery. So, how do we know that it's a series circuit?
Oh,
All right. The electrons come from where? Where do all of the electrons come from? Where's the power source? The battery. Okay. So the electrons will flow out of the battery and they travel through the wire, right? They pass through the light bulb. They cruise around through that wire, through the light bulb, back around. Let me fix breaking my wire here. All right, through that light bulb and back into the battery. Basically, it's a loop. Is there any place the electrons can go besides that loop? No. So it's one path. There's no place they can go aside from that path. Okay? So let me ask this. If a light burns out, okay, when the light burns out, what happens to the remaining bulbs? Okay, let's just say bulb 1 burns out. What would happen to bulbs 2 and 3 if bulb 1 burns out? Will they light or will they stay off? They will stay off. Okay, it's like having an open switch. If that bulb burns out, okay, if this bulb burns out, can the electrons jump over that big open space? The answer is no. It's like having an open switch. So these are like cheap Christmas lights. Okay, have you ever had cheap Christmas lights where one light burns out and the whole strand goes dead? Okay, if you have, those are series lights. Grace is nodding her head yes back there. I certainly have. Okay, you have a cheap set, you buy them for $1 at the Dollar Tree or something. One bulb goes out, the whole strand is dead. You have to chase down the burned out bulb and replace it to get the rest of the strand to come on.
There was a movie where
That's a series.
Whole, house of Christmas lights, and one was gone. They had to look at the whole Christmas light. I couldn't do it.
Christmas Vacation.
Yeah,
Probably with a dude in it.
Yeah, with a guy with the RV.
Motion.
Yeah.
All right. Everybody got what they need. Now, that's one that you're going to build tomorrow.
Wait. I'm starving.
Oh.
I didn't see all the stuff you have.
Is it on? Nope. No, we got to talk about parallel.
Oh my God.
That's 30 points tomorrow. That's only 30 on the lab.
30.
30.
Why can't it be 50 and
30. Okay, so where are the other 30 points coming from? Parallel. So what's a parallel circuit? This is a circuit with 2 or more paths for the electrons to follow. So if we do the same thing again, and I start with a battery, okay, this one would be parallel. Now, what makes this one different?
One more time.
Okay, now look at where the lights are. My electrons flow out of the battery. They can go down this path, or they can stay straight and go down this path, or they can stay straight and go down this path. It's sort of like we went down Main Street and we can turn down 1st Street, 2nd Street, 3rd Street, or 4th Street to get over to State Street. Okay? Doesn't matter which one of those roads we turn on to get to State Street. No, they all get us there. Okay? Does that make sense? Okay. Now, here, if I ask the same question and I number them bulbs 1, 2, and 3, okay, and this time I say, what happens if bulb 1 burns out? What would happen to bulbs 2 and 3 this time? The other 2 stay on, okay? So if you buy slightly more expensive Christmas tree lights, this time, if one of the bulbs burn out, what happens to the rest of the bulbs? They stay on. So a lot of you who, does anybody have a Christmas tree that's pre-lit? You buy artificial, it's pre-lit? Anybody buy one of those kind of trees? No? Okay. Well, if you do, all right, they have them on sale at Walmart, Lowe's, and that they always advertise at Christmas time. What kind of lights do they have? Do they have series or parallel? Parallel. Because would you pay $200 for a Christmas tree that if one light goes out, all the tree is dead? You would be very upset if you bought one of those high dollar trees and all the lights went out, wouldn't you? And you're out there like the guy in Christmas Vacation, as Trevor pointed out, taking bulbs out, putting bulbs in, checking individual bulbs on a pre-lit tree, trying to find the missing bulb. Okay? So if one of those bulbs dies, you need all the other bulbs to still do what? Still be on. Okay? Because you would not want to spend $200 on a tree that died because one bulb went out. Now, think about this. Is your house wired in series or parallel? Okay, I hear series, I hear parallel. So if you went out the door this morning and you turned the light out because you're the last one in the house, when you turn that light switch off, did everything cut off or did some things stay on in the house? Some things stayed on. So is it series or parallel? It's parallel. Because if everything cut off, it would be in series. Okay? Now, do you want a house that's wired in series? No, because you don't want the hot water cutting off. You don't want the refrigerator cutting off. You want some things to stay on. Now, do we have things in the house that are wired in series? It's possible. Now, there are a lot of homes that are not wired in series. I can't think of very much that's wired in series at my house. But my mother's house had a terrible electrician. Let me just point that out. You can't run certain appliances. Like you can't use a hair dryer in the air conditioning or a hair dryer in the microwave or a hair dryer in the iron. You can't use any of those appliances at the same time at any time or it blows the circuit breaker and you got to go out in the garage and reset it. Okay. But we'll talk about those things in a second. So in my mom's house, there's a whole wall that's wired in series so that you got a switch on the wall that you can turn on and off. Why would that be important? Why do you think he wired it that way? Anybody know?
No.
Have you ever wanted to turn a light like on a wall? Anybody got a lamp plugged in? You want to be able to turn off the lamp as you go in or out the door? A lot of times electricians will wire it so you can plug things into the wall and control it with a wall switch. Okay, so they'll wire it in series for that reason. All right, so on my mom's living room wall, all of the outlets are controlled by a wall switch. That's not a problem as long as you know that. So for years, my daughter, when she first got her cell phone, plugged her cell phone in on that wall. Well, what did my mom do every night before she went to bed? What happened to her cell phone every night? Dead in the morning. Okay? Took her 2 years to figure that out because we didn't visit all that often. So she's finally figured out it's got to be plugged in the kitchen because that wall, if it's wired in series and you turn that switch off, what happens to the power on that whole wall? It cuts off because it's wired in what? Wired in series. Now, if it's wired in parallel, when she turns that lamp off, would the rest of the outlets stay on? Yeah, they'd stay on if it was in parallel, but the whole wall is in series. So when she cuts that switch off, both outlets go out. Yes, sir.
I got a question. So at my house thing, we got 3 switches, right? And like one's for the light, one's for the fan, and then one turns both of them off. So what's that?
Parallel.
Okay.
Mm-hmm. Yep, they're all wired in parallel. All right, the last thing we need to talk about are safety features. And then we are done with notes. All right, there are 4 safety features we're going to talk about. Now, one that everybody's familiar with is a 3-pronged outlet or cord. All right, all of my outlets in here are 3-pronged outlets. You don't have to have a 3-pronged cord to use the 3-pronged outlet, but if you have a 3-pronged cord, there is a round part. All right, the round part is the ground or the safety feature. Okay? Do you have to have that piece in order to use it? The answer is no. All right? Many of you probably don't remember this. Do you remember back in the days of overhead projectors? Anybody remember seeing overhead projectors in classrooms?
Yeah.
Okay? I had once upon a time an overhead projector. I didn't actually use it in class. I only used it for an experiment. And I had it sitting over here along the wall, and the fire marshal came through. And he saw it, and because I didn't actually use it, I didn't worry about getting it fixed because the round part of the cord was broke off. He saw it, he came through with his wire clippers, and he cut the plug off. I was like, dang, man. So anyways, I had to have it rewired. My overhead projector worked just fine. I just plugged it in, went on about my business. But the fire marshal was all kinds of upset because my safety feature was gone. What is the round part for? Well, the round part plugs into the round part of this outlet. If there's extra electricity flowing through the cord, it flows through the round part, and the round part of that is wired into the ground, and it literally, the extra electricity runs into the ground and is dispersed. That's what's called ground. So, because mine was missing, we cut it off, threw it away, so that I can go see Mr. Butts. Mr. Butts rewired an overhead projector with a ground feature and the 3-pronged outlet on it. Okay? But if it's broke off, you can still use the cord. So, how many of y'all have circuit breakers in your house, apartment, garage? It's usually a gray box. It's usually in the bathroom, the hallway, or the garage. It's on the wall. Sometimes it's in the kitchen. Okay? These are switches. That are usually say tripped or flipped. Okay? All you have to do is turn off and on to reset those. They usually flip to the off position, and then you just turn whatever you've tripped, like a hair dryer, turn it off, and then go back out into the garage, the kitchen, or wherever, and turn the circuit breaker back to on. Okay, now if you don't turn the appliance off, when you turn the circuit breaker back on, it's probably going to trip or flip again. All right, but circuit breakers work on the same premise. When too much electricity is flowing, all right, the idea is if too much electricity is flowing, it can cause a fire. So when too much electricity flows, the circuit breaker will pop, will trip, will flip, whatever term you want to use. It shuts it down so you can turn off that extra electricity appliance and then go out and reset the circuit breaker. What did you say, Malik?
What you said about something about plug in?
Whatever's plugged in, you just have to turn it off. Okay? Now, fuses. Where do we see fuses at? Anybody know? What did you say over there, Yavion?
I don't know exactly what it's called.
Outside.
You usually see these in cars. Now, you can see them in some old circuit breakers. Okay? But it's got to be a really old circuit breaker to have a fuse in it. But some of them will be screw-in fuses and an old circuit breaker. All right? But typically they're in cars. All right? These melt and must be replaced. All right, so when too much electricity flows through a fuse, it just flat out melts, and you got to replace it. Okay, typically the people who have issues with fuses have changed out stereo systems or speakers in a car, and they're not manufactured specs anymore, and the amperage or the voltage or the current is too high, and it tends to melt the fuse.
Chinese stuff.
Okay, maybe so.
Alternate.
Okay, I'm not going to blame the Chinese, but it's not the manufacturer suggested specs, and so it does tend to melt the fuses, and so they have to be replaced.
$5 discount.
All right, and the last one is the ground fault circuit interrupter. Now, before you all go, what's that? This is the one that has the test and the reset button. Okay, now, where do you always find these? Bathrooms? One other place. Yes, why? Why do you always find these in the bathrooms in the kitchen?
So you don't get killed.
There's a reason. There you go. Very good. All right. It's because they're near water.
I said it.
Okay. You have to put those outlets in the bathroom and the kitchen because they're near water. Okay. It's required by code at this point. You can't not have those. So if you have an older home, you probably don't have them. All right, but if you have anything that's been built probably in the 90s, all right, maybe even the late 80s, you've got ground fault circuit interrupters. If you look at the outlets here in my room, you see the ones along the edge, they've got green lights on, they're ground fault circuit interrupters. They have the test and the reset button. If you hit the test and the reset and the green light's not on, please put the green light back on. Because when people go to charge their phones and it doesn't charge, they get mad. They're like, why am I on charge? Make sure the green light's on. All right?
I cut it off and cut it off.
It says test and reset.
Yes.
Okay?
What you mean? This is my charger. Don't ask me.
So a lot of times when you get like a hair dryer, it'll come in those big boxes on the hair dryer. That's a ground fault circuit interrupter for the same reason. That way, if you use it in a place that doesn't have a GCFI outlet, if there's too much electricity flowing through it, it will shut it down automatically. Okay? It's just a safety feature because if too much electricity flows through it, again, it could cause a fire. Because those are automatic safety features to shut it down. So if it gets water in the outlet, it shuts down. So it can't cause a fire. All right, so we're going to do our practice. So that tomorrow when you get here, what are we going to start with?
Our lab.
With our lab. Woo! All right. I punched the holes on the wrong side.
Why?
I'm paying attention. The side I want to do is the side with the picture, so we're doing the back side. Okay? And there's 14 questions. We should be able to finish this in 9 minutes before you leave, so we don't have homework.
Hey, stick
We may not be able to go over it, but we should be able to finish the questions. We shouldn't be able to have homework. We should be able to do 14 questions in 9 minutes. If not, it's homework. What? No, it's not. Work on it. That way, if you don't understand the diagram, I can help you. At the top.